All right, welcome to week 8, last assignment of the year. So this week what we're going to talk about is just one thing, and it's complex fractions. And yeah, it sounds complex because the word complex is in the name, but they're not that bad. If you remember back to when we were dividing rational expressions, a complex fraction is just division of rational expressions. So with one additional step, and that one additional step is we need to make sure that the numerator and the denominator are only one single fraction. So if you look at the two examples that we have up on the screen right now, the first one, the numerator and the denominator contain one single fraction. However, the second example, the numerator and the denominator both contain two fractions. And so before we can do anything with the second one, we have to turn that into one fraction in the numerator and the denominator. And once we do that, we can do what we need to do. However, there is also another method we can use to do that second one that I'll show you. I'll show you both of them so you can choose which one you want to do. All right, so the first one, since it's already one fraction, all we have to do is remember that this little bar here means division. And because it means division, we could rewrite this problem as 2x over 27y squared divided by 6x squared over 9. And if we remember, when we divide rational expressions, we just take the second one and we take the reciprocal of it and we change the division to multiplication. So what we can do here is we can say, all right, I have 2x over 27y squared, and I'm going to change that to multiplication and flip that second fraction over. And then this is where we would do all kinds of simplification, right? We would do all kinds of simplification. And with this one, yeah, we should probably do some simplification. So what I'm going to do is I'm going to just rewrite this first fraction as 2x over 9 times 3y squared. And the second one I'm going to write as, I'm going to write the 1 times 9. A lot of you won't need to do this, but if you don't do it and you forget that there's a 1 there, we can do some goofy things with it. So if you're one of those people that tend to forget that there's a 1 there, go ahead and write the 1 times 9. And then down here, I need to get rid of a 2, so I'm going to write this as 2 times 3. And I'm just going to do this. I'm going to write x times x because I'm going to cancel one of those x's as well. So I'm going to go ahead and cancel everything I can here. So I'm going to start with the 2, one of the x's here. And now this is one where I probably should have written the times 1 as well if you're one of those forgetful folks like that. And then let's see here. What else can I cancel? I can cancel the 9. And that's it. So I'm going to go ahead and multiply across now. So I have 1 times 1 is just 1 for my numerator. And then my denominator, I have 3 times 3 is 9. And then I have a y squared and an x. I'm going to put the x first just because it's alphabetical order. And we prefer alphabetical order if we can. But it wouldn't matter. If you put the y first, it doesn't really matter. It's the same thing since it's multiplication. So there we go. We have simplified that complex fraction by dividing and then multiplying. Okay, so there's the answer right there. And this one is pretty straightforward. There's not much else we can do to this one because it's already in the form of a single fraction, and we just do what we need to do. All right, the second one, though, there are a couple of different ways we can do this. And the first way we can do this is to turn the numerator and the denominator into a single fraction. And what I mean by that is find a common denominator. So if you look at the numerator and the denominator, in this case the common denominator for both of them is x squared. And so when we have a common denominator like that, what we need to do is obviously multiply the other fraction by whatever we need to multiply it by to make the common denominator, right? So that one's going to be multiplied by that, and the denominator is going to have the same thing going on, right? And so when I do this, I'm only multiplying that second fraction. I'm not multiplying the first fraction because I only want that second fraction to change. So we have So we have 2 over x squared plus, oops, I just wrote down there, plus, in this case, the second one becomes x over x squared because I'm multiplying by x across everything, right? And then the denominator of the whole thing is 4x squared minus x over x squared. So same thing. So in this case, we end up with the same thing on the right-hand side because we started with the same thing, 1 over x, right? And so now we can combine these two fractions in the numerator. So we have 2 plus x over x squared. And then we have 4 minus x over x squared. Okay, so now we have a single fraction in the numerator and the denominator, so we can do our little division trick. So we have 2 plus x over x squared divided by 4 minus x over x squared, and then we flip the whole thing over, right? And we change it to multiply. So I'm going to go ahead, what am I going to run out of room? No, I'm all right. So I can change this to 2 plus x over x squared times x squared over 4 minus x. Okay, and then I cancel what I can cancel, right? So in this case, that can actually cancel. And then the other two are binomials. And I know some of you struggle a bit with the idea of binomials being one thing and we can't separate them apart. So don't try to cancel the x's here or one of the 2's. We can't do that. So we have to just write this as 2 plus x over 4 minus x. And that is it. We are done. Okay, so there is a second method for doing this that you might like better. And I'll show you how to do that. So one thing to think about is we know that our common denominator is going to be x squared. And this method is pretty similar to what we just did, but it's just kind of a little shortcut method. So I'm going to go ahead and write the problem again. And we have 4 over x squared minus 1 over x. Okay, we know the common denominator for all 4 fractions in this case that are in this problem is x squared. And so we know that if we multiply everything by that common denominator of x squared, that's going to cancel, that's going to cancel. And then when we multiply the other 2 fractions by x squared, only one of the x's is going to cancel. So this is going to cancel and we're going to have an x left. This will cancel and we have an x left. Okay, and so you can see what we just did was we got rid of all of the denominators, right? So now we have 2 plus, now it's 1x, but I'm just going to write it as x. And then we have 4 minus x. And so you can see we quickly got to the answer that way instead of having to do all the extra writing up above. Okay, so if this is something that you like, where you just say, hey, I can multiply everything by the common denominator, and it eliminates whatever the denominator is, and leaves behind something if it needs to, in the case of the 2 fractions on the right, do it, because it's a lot faster to do it this way. Okay, so this next one, we can also do the same thing to this next one because we have a common denominator of x. All right, and so we don't even have fractions for some of these, for the first 2, in each, the numerator and the denominator, but we have a common denominator of x, and so when we have a common denominator of x, we know it's going to cancel those x's, and then this we're just going to multiply by x, and this we're going to multiply by x. Okay, so everything gets multiplied by that common denominator. Okay, so in this case we end up with 2x over 4x squared. And then we can simplify this a little bit, and if I'm going to write it all out just because I like to show the whole thing. Okay, so that's how it looks, and then I'm going to have to switch colors to cancel. I'm going to use blue this time. Now this one probably should have done the 1 times right there, but you don't have to. If you can remember, those cancel. If you can remember that anytime the numerator completely disappears, it needs to be replaced with a 1. That's what we need to worry about. Okay, and so in this case we end up with 1 over 2x. Okay, and you could use the other method to do this, where we find a common denominator of x, and I'll just get it started, and then if you want it, you can finish it from there. So if we have a common denominator of x, and we're going to find that common denominator for both the numerator and the denominator, we would multiply. Now in this case, we would have to put these over 1, and we're going to multiply this by x over x. And here we do x over x as well. Okay, and so you'll end up at the same spot. It's just you're going to do a little extra work. All right. Your gift this week is only 3 problems. No, 4 with the challenge. Try the challenge. It looks goofy. You got a fraction in a fraction in a fraction. So give it a shot.